In this video, I'm going to be covering question 2, part C from the 2019 AP Calculus AB Free Response Calculator Required portion of the exam. I cover A, B, and then C and D all in their own separate videos, so if you want to see solutions to those other problems, please check out my other videos. So let's look at part C here. So we've got a second particle now, which means we don't have to worry about that table up at the top. And it moves along the x-axis so that its velocity between these values here are given by this equation. So there's our velocity equation. And they want us to find, first and foremost, there's two parts of this. First, they want us to find the time interval during which the velocity of that particle is at least 60 meters per hour. And then they want us to use that information to find the distance traveled over that time interval. And so what we'll do is we'll start off by finding the first piece. Let's see, when is our velocity going to equal 60? So to do that, what you're going to do is you're going to take that velocity equation, so 45 square root of t times the cosine of 0.063 t squared, and we want to know when is it at least 60. So we want to set that equal to 60, and at least 60 means it needs to be above 60. So we're looking to find the interval where this first velocity equation is above 60. Conveniently, this is a calculator required portion of the test, so we can do this pretty quick and easy in our calculator. So the first thing we're going to do is we are going to shove this first equation into y1. We'll take and plug our second equation into y2. This is a classic, what I call something equals something. We're going to set them equal to each other and then pop them into the calculator. We'll then graph those two equations. When we go to graph this, we're going to want to adjust our window on here. And we're going to want to adjust our window for two reasons. One is we know that our x's that we care about, our interval is limited to 0 to 4. So we don't care about intersects that happen outside that window. So we would want to go ahead and adjust our x min to 0 and adjust that x max to 4. Then whenever you've got a number by itself as what you're setting it equal to, that's just going to be a straight line at whatever that number is. So we're going to have a straight line at y equals 60. So if we're going to see that straight line, we want to make sure that our y max is above that number. So above 60, I'm going to set it to a nice equal 100. Then from there, we're going to go ahead, once we graph it, we're going to do a second calc, and then inside the calc menu we'll choose the number 5 option, which is intersect, and that'll tell us where it begins and ends being above 60, so at least 60. So let's open up our calculator, go to our y equals, we'll type in that first equation, so 45. Anytime you're doing graphing, you always want to use an x, no matter what they call the variable, always just type in an x. So then cosine of 0.03x squared. And then from there, we want to know when does that equal 60. You also want to make sure whenever you're doing trig graphing, this entire test is in radian mode. So you want to make sure your calculator is in radian mode to start with. If it wasn't, check it, hit the mode button, and just kind of make sure that you're in radian mode. You should just have your calculator default set there and never change it for the whole test. So let's go ahead, and now that we know we're in radian mode, let's adjust our window. So we want to do an x min of 0 and an x max of 4. And then we also want to go down and adjust that y max to make it above 60. So I'm going to put that up to 100. I adjust the scale. That's just the tick marks of where the graph is. I just like my graphs to look nice. So I hit graph. And now I can see my two intersects happening. I want to know when it's at least 60, so I want to know when it's above that red line. The red line is where 60 is at. So in between my left intersect and my right intersect is where the blue graph is above 60. So that's the interval I'm looking for. And now we go find those values. So I'm going to hit second, calc. I'm going to choose that number 5 option, which is intersect. So I hit enter. It's now going to ask me a series of 3 questions at the bottom of the graph there. It's first going to ask me for a first curve. So just go ahead and hit enter on that. It'll switch automatically to the second curve and ask you for the second curve. So hit enter again. And it's the third question, the guess, that we really care about. So the first time through, I'm just going to scroll my cursor so I'm closest to that intersect on the left. I'm going to hit enter a third and final time. you'll know you did everything properly because it's going to say the word intersection at the bottom of the screen, and that x value is what you want to be looking at here. So for this problem, because we're going to need to use these values later on, we would want to, normally final answers you'd round to 3, but when you need to keep working with a value, you really want to take it out to 6 decimals. So this would be 1.866181. So x equals 1.86, what was that, 866181. And then we want to go ahead and go find that other intersect. So we just start the process over again. You hit second, choose that calc menu up at the top there, and then again choose that number 5 option, intersect. First curve, yep, hit enter. Second curve, yep, hit enter. And then this time, when it asks us to guess at the bottom of the screen, we're just going to scroll over to the right so we're closer to that other intersect. And once you're close to it, hit enter a third and final time. And that's going to give us our other intersect of 3.519174. So x equals 3.519, what was that, 174? 174. So they want the interval. So when you go to give them the final answer on this, the interval is going to be that when it's 1.8, and then when you give them the interval, you can go ahead and round to 3 decimals. That's what they want on the final answer. So whenever this is greater than that value and less than 3.519, it is at least 60, meters per second, or no, meters per hour. Aren't they tricky? So at least 60 meters per hour. So that's the first part of this. And now the second part wants to know distance traveled. When we're talking distance, remember distance wants us to treat all area as positive. Distance traveled is an integral setup. It's the integral from A to B of the absolute value of whatever your velocity equation is. So for our problem right here, we would set this up and we would say this is going to be the integral from our lower bound, which would be the 1 point. And again, when you're doing when you're not getting the final answer, you want to use the larger, longer decimals. So from that 1.866181 up to our upper interval of that region, which was 3.519174. And we're going to do this of our velocity equation, the equation that they gave us to work with here. So this is 45 square root of t, and then times the cosine of 0.063 t squared dt. And again, the great news here is we can do all of this in our calculator. To find this out, and remember this is the absolute value, so when we go to put this in, we would have absolute value bars here, and we would want to also do the absolute value as we graph it. So in y1, we would put the absolute value of 45 square root of t cosine of 0.063 t squared, close that absolute value. And now you would go ahead and graph that. And then this time we want to find that antiderivative. So we would do a second calc, and in the calc menu we'll choose this time the number 7 option, which is integral of f of x dx. It'll ask us for our lower limits and our upper limit. We'll put those in, and we will get out our answer at the bottom of the screen. So opening back up our calculator, if you're good at this, you can use the insert button so you don't have to retype this. I hit second and then insert, and then the absolute value bars are under math, and then num, and then number 1 ABS. Oh, and the calculator doesn't like that. It needs us to go ahead and type all this back inside those absolute value bars by hand. So I thought I was going to be slick there, but apparently I'm not, and we're just going to have to go back through, type that full equation back into the absolute value bars. So 45 square root of x cosine of 0.063 x squared. Close that, and then we've got the absolute value bars. And then you saw that I went and deleted out 0 from the y2 because we don't want to graph that. And now we'll hit the graph button, and we'll go through and we'll do second calc, and then this time in the calc menu we'll choose that number 7 option, integral of f of x dx. It wants the lower limit first. It's asking that on the bottom of the screen, so we'll type in our lower bound, the 1.866181. 181. Hit enter. It'll then ask us for the upper limit, the upper bound, and we'll type in that upper value. So 3.519174. We hit enter, it shades it in, and at the bottom of the screen you can see that it gives us the integral of f of x dx equals 106.10, and I would round that up to a 9 because they want 3 decimals on their final answer. So we get out of here 106.109. And then it's a total distance traveled. And since we're talking meters on this problem, meters per hour, this would be meters. So that would be our total distance traveled. This problem would have ended up being 3 points. We would have gotten 1 point off of here for getting our interval correct. We would have gotten 1 point off of here for setting up the proper definite integral. And then we would have gotten 1 point for getting out that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.